In this video, I'm going to show you what is a Riccati differential equation and how we can solve these type of differential equations. In general, a Riccati differential equation is in this form. Y prime equals to a of x times y, a function in terms of x times by y, plus b of x times by y squared, plus c of x, another function in terms of x. This is the general form of a Riccati differential equation. If we have a particular solution of the Riccati differential equation, so say y1, so let's suppose y1 to be the particular solution of a Riccati differential equation, then we can find the general solution, the other solution of the Riccati differential equation with this substitution. If we suppose y to be y1 plus 1 over v, with this substitution, we can find the general solution of the Riccati differential equation. With this substitution, we can convert a Riccati differential equation to a linear first order differential equation. Note that for doing this substitution, we have to have y1, we have to have a particular solution of the Riccati differential equation. And in the questions, usually when they ask to solve a differential equation in the Riccati form, they give this particular solution. Let me show you an example. Y prime equals to negative 2xy plus y squared plus 1 plus x2. Note that in this Riccati differential equation, negative 2x is a of x, coefficient of y is a of x, and a of x in this example is negative 2x. The coefficient of y squared, b of x, is 1 here. So b of x here is 1, and this part is actually c of x. So we have a Riccati differential equation in the standard form. For solving a Riccati differential equation, we have to have a particular solution of the differential equation. And for this question, we are given a particular solution, y1, a solution of this is given x. So the function x is a solution of this differential equation. We know this in advance. We have this. Now we want to find the general solution of this equation. Before we start to solve this differential equation, let me show you why x is a solution of this Riccati equation. Y prime derivative of x is 1. It should be equal to negative 2x times by y, y is given x, plus y squared, which is x squared. Note that y is x, so y squared is x squared, plus 1 plus x. We write this here. Now the two sides should be the same. This is negative 2x plus x2 is 0. So in the right side we have 1, and in the left side also we have 1. This shows that this given function here is a particular solution for this equation. But here we want to find the other solution. For finding y, we use this substitution. So we say y equals to, let me change the color, y equals to y1, which is given x here, plus 1 over v. So here we want to replace y with v. For using this substitution, note that first we have to find y prime, because we need y prime to replace in the differential equation. If we take derivative from both sides of this equation, we have y prime equals to derivative of x is 1, and derivative of 1 over v is negative 1 over v squared times by v prime. Let me show you why derivative of 1 over v is this. If we use quotient rule, derivative of the top is 0 times bottom is 0 minus right numerator 1 multiplied by derivative of the bottom v prime. Derivative of v is v prime all over v squared. Note that v is a function, so derivative of v is not 1. Because v is a function, derivative of v is v prime. And this shows that derivative of 1 over v is negative v prime, as we have here, over v squared. So derivative of 1 over v can be written as negative v prime over v squared. Now here in this equation, if we replace y prime with this, we have 1 plus negative v prime over v squared equals negative 2x times by y. What is y? Y is this. X plus 1 over v plus y squared. So we have to square this. We have to raise x plus 1 over v to the power of 2. And finally plus 1 plus x2. Now we have to try to simplify this. Note that we can cancel this one here from the left side with this one in the right side. So in the left side of the equation only we have negative v prime over v squared. In the right side, if we multiply negative 2x in the bracket, we have negative 2x2 minus 2x over v. And if you raise this bracket to the power of 2, we have x squared plus 2x over v plus 1 over v squared. For raising this to the power of 2, you can use this identity. A plus b squared is a squared plus 2ab plus b squared. Or you can simply multiply x plus 1 over v by itself, and simply you can get this. If you multiply these two brackets, you can get to this expression. Plus 1 plus x 2. Now if you look at the right side, this x2 and this x2 cancel each other, and I forgot to cancel this 1. So because we cancel this 1 with this 1, so I should not write 1 here, so only we have x2 here. Again, this 1 cancels with this. Now note that x2 here and this x2 and this minus 2x2 cancel each other. So this term, and this term cancel each other, and 0 remains. And negative 2x over v and positive 2xv also cancels. So let's see what remains. In the left side, we have negative v prime over v squared. In the right side, only this 1 over v squared remains. Again, these terms cancel each other, and negative 2x over v and positive 2xv over v cancels. So suddenly everything simplified. Now, if we multiply both sides by v squared, or if we cancel this v squared with this v squared, we get to this really simple equation. Negative v prime is 1. which if we multiply both sides by a negative, we have v prime equals -1. Don't forget v prime is actually dv, derivative of v, with respect to x. X is the independent variable. Because dv over dx is 1, derivative of v is -1 actually. Sorry, not 1. -1, -1. So from here, v equals -x plus c. If we integrate -1, we have -x. And this is v. Now from here, we have to find y. Don't forget y is x plus 1 over v. So y equals x plus 1 over this -x plus c. And this is the general solution of this Riccati equation. Now let me show you another example. The next example is this equation. Y prime is given -1 over x squared minus y over x plus y squared. And the particular given solution, the particular answer of this Riccati equation is 1 over x. So we have the particular solution and we want to find the general solution. Before we start, let me show you why 1 over x is a particular solution. This is a good exercise to do here. Y prime, derivative of this, is -1 over x. It should be equal to -1 over x minus y over x. If we divide this y by x, we have 1 over x divided by x, which equals 1 over x2. So we have -1 over x2 again, plus y squared. If we square this, we have 1 over x. This cancels with this, and -1 over x2 and -1 over x2 are equal to each other. So this shows that this given particular solution is really a solution. It's not necessary to check this, but I wanted to show you how we can check if a function is a solution for a differential equation. Let's back to our question. We want to find the general solution. Again, we have to do the same process as the previous example. We suppose y to be y1, which in this case is 1 over x plus 1 over v. And then we have to find y prime from this. The derivative of 1 over x is -1 over x2. With a simple quotient rule, you can check this. And the derivative of 1 over v is -v prime over v squared. Now if we replace this y prime with this, we have -1 over x2 minus v prime over v squared equals -1 over x2 minus y over x. Y is this expression, and we have to divide this by x, or in another way we can say we have to multiply this by 1 over x. Let me show you how you can calculate this. We want to find y over x, and y is this. Note that instead of dividing y over by x, you can say y over x is actually 1 over x times by y. This expression is the same as this expression. If we multiply y by numerator, we have the same expression. Now if we multiply 1 over x in this bracket 1 over x plus 1 over v. We have 1 over x2, this multiplies by this, plus 1 over x times v. So, minus this, so don't forget we have minus 1 over x2 minus 1 over x. Let me clean here. Okay, plus y squared. We have to square this. Again, if you multiply this expression by itself, or if you use the identity, this expression s squared is 1 over x2 plus 2 over x v plus 1 over v squared. Now let's see what simplifies from the two sides of this equation. Negative 1 over x2 and positive 1 over x2 cancels. Negative 1 over x2 with the negative 1 over x2 in the other side cancels. Again, this is negative 1 over x2, this is plus 1 over x2 equals 0. And if we move this to the other side, it becomes plus 1 over x2, so cancels with the other one. So, all the 1 over x2 cancels. What remains in the left side is just this negative v prime over v squared. In the right side, we have negative 1 over xv plus 2 over xv. So, if we add this to this, we get 1 over xv. And finally, this 1 over v squared remains here. Now, if we multiply both sides of this relation by v squared to get rid of this v in the denominator, so we multiply both sides of this equation by v squared. Actually, the idea is to convert this to a first order linear differential equation. Always, with this substitution, in general, we can convert Riccati equation to a first order linear differential equation. To do so, we multiply both sides by v squared. Note that here it's not necessary to multiply both sides by v squared and x to get rid of this x. It's better to leave x here. So we only multiply both sides by v squared, sorry. So we have negative v prime equals, if you multiply this by v squared times by 1 over xv, 1v with v squared cancels, so we have v over x, or 1 over x times v. It's the same. And if we multiply this by v squared, we have 1. Now if we look at this is a really simple first order linear differential equation. If we move this to the other side, we get to this equation. V prime plus 1 over x v plus 1 equals 0. Now we want to solve this simple linear first order differential equation. If you remember, for solving a linear first order differential equation in general, first we have to find the integrating factor. Let me remind you how we solve a general differential equation in this form. First, we have to find the integrating factor, which is e to the integral of px dx. This is integrating factor, mu. Then the answer is 1 over mu, whatever we get from here, integral of mu times this function q of x dx plus c. So in this way, we can find, in general, linear first order differential equations. So similarly here, we want to do the same thing. First, for finding the integrating factor, if we name integrating factor to be mu of x equals to e to the power of integral of whatever is here. Integral of 1 over x dx. Integral of 1 over x is ln of x. And e to the ln of x is x. We know that e to the ln of any expression equals the same expression. So x is the integrating factor. And from this, we can say v, the solution of this differential equation, equals to 1 over this. So 1 over x times by integral of mu of x, which is x, times by q of x. Actually, to use the method that I described here, the q of x is the function that is in the right side. So we have to bring this 1 to the right side, and that's the q of x. So here, if I bring 1 to the other side, this equals negative 1. So this equals negative 1. So integral of x times by negative 1 dx. Again, to use the method that is described here, the q of x is the function that is in the right side. So we have to bring 1 to the other side. That's the reason I bring 1 to the other side. Okay, plus c here. Don't forget to add c here. Integral of negative x is negative x2 over 2. So from here, v equals to 1 over x times by negative x2 over 2 plus c. If you like, you can multiply this 1 over x in the bracket, which if you do so, we have negative x over 2 plus c over x. If you multiply this 1 over x in here, 1x with x2 cancels, 1x in numerator remains. So we have negative x over 2. And if we multiply 1 over x by c, we have c over x. So now we find v. So if we replace this here, our general solution is y equals to 1 over x plus 1 over this, negative x over 2 plus c over x. And this is the general solution of this Riccati equation. And of course, if you like, you can do a common denominator here, and then you can simplify this. It's up to you to simplify or leave your answer in this form. This is the general solution. Let me show you one more example in this video of Riccati equation to get more familiar with this procedure. Doing more examples help you to learn these techniques better. Actually, solving differential equations is not hard, but because the steps are a lot, you have to get familiar with these steps by doing lots of examples. That's the only way that you can learn how to solve this type of differential equations. The next example is a bit harder. X times by x squared minus 1y prime plus x squared minus x squared minus 1y minus y squared equals 0. And the given particular solution is x2. we want to solve this Riccati differential equation. First of all, you can simply check to see if this is a particular solution of this differential equation. Let me show you why this is a solution. If we take derivative of this for y prime, derivative of x2 is 2x. So we have x times x2 minus 1 times by 2x plus x2 minus x2 minus 1 times by, again, x2, y is x2, minus y squared is x4, it should be equal to 0. If you multiply these brackets, finally you get 2x4 minus 2x2. Here we have x2, and if we multiply x2 in this bracket, we have negative x4 plus x2 minus x4. If you look carefully, x4, x4 and 2x4 cancels, negative 2x2 plus x2 cancels, so 0 equals 0. So this is a solution. Now we want to find the general solution. So first we suppose y, the general solution, to be y1 x2 plus 1 over v. Y prime equals to 2x plus derivative of 1 over v is negative v prime over v squared. Now here, if we replace y prime with this, we have x times x2 minus 1 times by 2x minus v prime over v squared plus x squared minus x2 minus 1 times y, which is this, x2 plus 1 over v minus y squared, this squared. As you can see, compared to our previous examples, this is a bit harder question. If you want to compare this equation with the standard form of a Riccati equation, note that in the Riccati equation, the general form is ax times y plus bx times y squared plus c of x. So if you want to convert this to this form, first you have to move all of these terms to other side and then divide this. But it's not necessary to do so. So I left it in the original form. But if you want to find what is a of x, what is b of x, and what is c of x, first move these terms to other side, divide by coefficient of y prime, then you can find out what is a of x, b of x, and c of x. Let's back to our question. Now we have to simplify this expression. First note that if we multiply x in this bracket, we have x to the 3 minus x, which if we multiply x to the 3 minus x in this bracket, we have x to the 3 times 2x, 2x to the 4. If we multiply x3 by this, we have minus x to the 3 v prime over v squared. If you multiply negative x by 2x, we have minus 2x2 plus x, what happened here, v prime over v squared. We multiply negative x by this and we get plus x v prime over v squared. Zoom here, okay, plus x squared we write this x squared. If we multiply this bracket in this bracket, term by term, we have negative x4 minus x2 over v plus x squared, and finally plus 1 over. When you want to multiply this bracket in this bracket, don't forget this negative for every term. So x2 times x2 is x4, but we have this negative, so negative x4. When we multiply x2 in 1 over v, it's x2 over v, but again, because of that negative, negative x2 over v. When we multiply this negative by x2, we have negative x2, but because of that negative, it becomes positive x2. And finally, negative 1 times this is negative 1 over v, and then it becomes positive 1 over v. If we raise this bracket to the power of 2, but don't forget we have this negative for every term, so we have negative x4 minus 2x2 over v minus 1 over v squared. If you don't know the identity, simply multiply this by itself and you can get to this. Don't forget again this negative. Now let's simplify this big expression. Let's see what remains after simplifying. Note that for v prime, the terms with v prime are these two. So we have negative x to the 3 over, let's write it as v prime over v squared, plus this x v prime over v squared. X squared and x squared is 2x squared, cancels with this negative 2x squared. 2x4 minus x4 minus this x4 cancels. And finally, we have this negative x2 over v and this negative 2x2 over v, which the sum of this term with this term is negative 3x2 over v. So we have negative 3x2 over v. And also this 1 over v remains here, plus 1 over v. And also this term remains, minus 1 over v squared equals 0. So we get to this differential equation. Now to get rid of these v's in the denominators, let's multiply both sides by v squared. So if we multiply both sides by v squared, we have negative x3 v prime plus x v prime minus 3x2 v. If we multiply this by v squared, 1 v goes in top. 1 v cancels with the bottom and 1 v remains in top. If we multiply this by v squared, we have v minus 1 equals 0. Now here, between these two, if we factor from negative x3 plus x times v prime, we factor v prime from these two. And in these two terms, if we factor v, we have negative 3x2 plus 1 times v. And if we move this negative 1 to the other side, this equals 1. Now this differential equation finally is a first order linear differential equation. This equation is in this form: y prime plus p of x y equals q of x. But actually we have to make coefficient of y prime equal to 1, then it is in the standard form. So to really make it like this, first let's divide both sides by negative x3 plus x, because in the standard form the coefficient of y prime is 1. So if we divide both sides by this, we have v prime plus negative 3x2 plus 1 over negative x3 plus xv equals 1 over negative x3 plus x. Now for solving this differential equation, first we have to find the integrating factor. Integrating factor for this first order linear differential equation is e to the power of integral of this, integral of negative 3x2 plus 1 over, write this here. The integrating factor equals to e to the power of integral of negative 3x2 plus 1 over negative x3 plus x dx. For finding this integral, note that if we choose u to be equal to this, equal to the denominator, then the derivative of denominator is exactly on top. So for finding this integral, we do a u substitution, which suppose u to be negative x3 plus x, and du is negative 3x2 plus 1 dx. So this integral becomes du over u, e to the integral of du over, and integral of du over u is e to the ln of u. And don't forget u is this. And e to the ln of any expression equals the same expression, equals u. And u is negative x3 plus x. So finally, the integrating factor is simply negative x3 plus x. So this integral equals to e to the ln of negative x3 plus x, which equals negative x3 plus x. This is the integrating factor. So v equals 1 over integrating factor, 1 over mu of x, negative x3 plus x, times by integral of mu of x, negative x3 plus x, times by q of x, which is 1 over negative x3 plus x, plus dx, plus c. This times this, because they are reciprocal of each other, is 1. So this equals to 1 over negative x3 plus x times by x plus c. So note that this is equal to 1, and integral of 1 is x. Now, if we want to find the general solution, if we use our substitution for finding y, we can write our answer as y equals to x2 plus 1 over this. Note that we can write this as x plus c in numerator and this in denominator. And so 1 over this, because y equals x2 plus 1 over v, v equals this, and 1 over this is reciprocal of this, which means that we have to change numerator with denominator. So we can write this as x2 plus negative x3 plus x over x plus c. So this is the general solution of this complicated Riccati equation. I hope by watching this video you have learned what is a Riccati equation and how to solve it. If you liked my video, please subscribe in my channel and see you in the next videos.